look at this zinc copper cell and using your standard electrode potential table, figure out where oxidation is going to happen, where reduction will happen, and which is the oxidizing and which is the reducing agent. Only then should you continue with the video. Here we have zinc's position in the table and there is copper's position in the table. We have both zinc and zinc ions present. We have both copper and copper ions present, so the availability of the chemicals isn't the issue here. Now we need to decide, well, which is going to be oxidized, which is going to be reduced. And so we know that the higher up to the right a chemical is, the stronger it is as a reducing agent. So zinc is our strongest reducing agent that we have. So it's going to be the reducing agent. The reducing agent is oxidized, so it is going to be oxidized. It's going to change from zinc to zinc ions. How is it going to do that? Well, it will have to lose 2 electrons, set 2 electrons free to do that. Those 2 electrons then are free to travel in the external circuit and to go to the other electrode. Just note that by zinc losing those 2 electrons, that changes the zinc atom into a zinc ion which is soluble, and because it's soluble it then moves away from the zinc electrode and it goes into the solution, and that corrodes, it eats up the electrode, decreasing that electrode's mass. Alright, let's continue then with copper. So we've seen that the lower down to the left on this table, the stronger the oxidizing agent. Copper ions are the lowest down to the left of those present in this particular cell. So that's going to be the oxidizing agent. The oxidizing agent is reduced, and so copper ions are going to be reduced to copper atoms. How can copper ions be reduced to copper atoms? Well, they have to absorb electrons, and by absorbing electrons they change from copper ions to copper atoms. So zinc is the strongest reducing agent present, so it is oxidized. Copper ions are the stronger oxidizing agent of those present, and so the copper ions are reduced. How do the electrons move in the external circuit, and which electrode is the positive electrode and which the negative? Also, write down the half reactions for the oxidation half reaction and the reduction half reaction. There we have the oxidation half reaction. Zinc gets changed into zinc ions with the release of electrons. Copper ions absorb electrons to change into copper. Which electrode is positive or negative? Now, because the zinc electrode is oxidized, meaning it loses electrons, electrons are set free as the zinc changes into zinc ions. And so since there is a dumping of electrons onto the electrode, set free now by the zinc releasing them as a change to zinc ions, now that makes that electrode more negative than it was before that reaction happened. Meanwhile, the copper ions, they take in electrons, and in so doing they change into copper atoms. So by them sucking in electrons, they're removing the amount of electrons free within the electrode, and so that makes that electrode positively charged, and electrons flow from negative to positive. That is not the same thing as conventional flow. Conventional flow is from positive to negative, but here I'm not referring to conventional electrical flow. I'm referring to electron flow. Now, which electrode is the anode and which is the cathode? Anode is the electrode where oxidation happens. We remember that by each beginning with a vowel, and cathode, the one where reduction happens. So in this case, the negative electrode must be the anode because oxidation happens there, and the positive electrode must be the cathode because that's where reduction happens. Here is a list of questions which you should try to answer yourself before you continue with this video. At the zinc electrode, oxidation is happening. The zinc atoms, which were making up the zinc electrode, are continually being oxidized, changing into zinc ions and going into solution as a result, because the zinc ion is soluble, whereas before the zinc atoms were not. And so what that does is it increases the zinc ion concentration, and since zinc ions are positive, it also makes the whole solution more positive than it was before. In a way, the opposite is happening on the other side, because before you had a whole lot of copper ions bathing the electrode, and now once they're become reduced, once they take in electrons from the electrode, then they change into something that isn't soluble, copper atoms, and these copper atoms, they precipitate. And so what this does is it reduces the amount of copper ions, the concentration of copper ions in the solution, and it also makes the solution to be less positive. So now, because of this, we have a potential difference that exists between the two electrolytes, and that draws positive ions across through the salt bridge to equalize this potential difference that had been created. And this also completes the circuit. It also prevents a buildup of charge. Now, only one thing remains for us to understand the zinc copper cell, and that is, what would the potential difference be between a zinc and a copper electrode? And this is what we'll start to understand in the next video.